All right, now on to the actual review. Let's do problem statement 1 all in one video. The height of the ball is kicked in the air is modeled by the equation h equals negative 2t squared plus 36t, where h is my height, and that's in feet, and t represents the number of seconds. Let's see. First off, I want to create a table. Now, you've got a few options here. You could plug in each of these x values into your t value, or sorry, each of these t values into the equation, or we can go about the easy way. Let's go ahead and use that calculator and go to the y equals screen, and let's go ahead and type it in, negative 12. Now, we can't use a t on the calculator, but we can use an x, plus 36x. And now we're going to go to our table, which is second graph, but I've got a slight problem with it. Here I've got 0.5, 1.5, 2.5, and this one only has 1, 2, 3. It's jumping by ones. So we've got to readjust the table so it'll show me decimals. The way we do that is right here, table set. Go second table set. Table start, 0 is where the table starts at. You'll notice that when we go back to the table, 0 will be the first value. And then delta table is how much it's changing by. So we don't want it to change by ones. In this case, we want it to change by 0.5s. So let's change that to 0.5. Go back to our table. And we've got our values 0, 15, 24, 27, 24, 15, and 0. Now with that complete, let's go on to B. Graph the function on the grid. Well, let me go ahead and zoom in so we can see that a little bit better. First thing we got to do, and even reminds us to do that, is label and scale your axes. So my horizontal, my independent variable, is going to be, in this case, time, which is seconds. Time in seconds. And I need to go all the way at least to 3 on there, and I probably should be skipping by 0.5s. So let's go 0, put a 1 there, 2, 3, 4, and 5. Now my horizontal axis needs to be my other variable, which is height. And we'll put that in feet. And now all I've got to do is graph all my points. My first one was 0, 0. Oh, I'm sorry. I'm going to have to scale it first. Now I've got 10 lines going up, and I need to get at least to 27 is my maximum value. So that tells me my easiest thing is just to count by threes. So 3, 6, 9, 12, 15, 20, 18, 21, 24, 27, 30. So I've got 0, 0, 1, or sorry, half 15, 1, 24, 1.5, 27, 2, 24, 2.5, 15, and 3, 0. Let's go ahead and sketch that curve. And there we go. I've got a nice curve of, or a nice graph of my curve there. Now let's go ahead and move on to the rest of it. Reasonable domain and reasonable range, part C. Reasonable domain. Anytime we have a problem situation, we have a situational domain. To do our situational domain, we have less than, x less than. Start with the inequality sandwich. We're just going to put our smallest and our largest. Our smallest x value that we use is 0. Our largest x values we use is 3. For range, we do the same thing. Start with our sandwich, gives me a y. The smallest y that we use is 0. And the largest y that we use is the max, which is 27. Now, what is the vertex? Now, if you remember, vertex is the peak or the valley. In this case, it's a maximum, so it's a peak. The coordinate pair for that point is 1.5, 27. Now, for part E, what does the vertex represent in the problem? Well, in this case, we don't want just some gibberish about 27. We want what it represents as a part of the situation. Now, what this graph is showing us is how high a ball goes up in the air. So it's showing us the ball is going up, slowing down, then curving back down towards the earth and eventually landing right here. So this point could represent, well, how high the ball went before it fell. So what does the vertex represent? The ball rose 27 feet before it fell. Now, I'm sure there's a much better way of writing that, but anything that you can put there to let your teacher know that you know that that thing is talking about a ball rising and then falling. Okay, you could say something about the maximum height of the ball was 27 feet, something to that effect. Now, predict the time it takes for the ball to touch the ground, part F. Well, the ball touches the ground, looks like again here at 3. So, it is 3 seconds.